Astronomy has long ago determined that the Earth's place in the universe is completely ununique, meaning that there can be many, many Earth twins out there. Picking up on this point I made in my short film about the significance of reviving the extinct thylacine, it has been known for some time now that the position of our Earth and our solar system in the context of the entire universe is not unique at all. In ancient Greece, over 2,000 years ago, they had no telescopes. What they did have was a cultural emphasis on learning and asking tough questions about their world and about themselves and about nature. However, without telescopes, all they knew about what they saw in the night sky, they knew from looking with their own eyes. There was a big, bright sphere in the sky, the sun, and at night, lots and lots of far smaller points of light in the sky, the stars. The philosophers wondered whether the stars and the sun were really all the same thing, but without telescopes, there was no way that they could pursue the matter further. All they could see was that the sun, when viewed through a dark cloud, can indeed look very much like a star. Ancient people saw the same night sky that we see today. The stars aren't distributed all evenly, as though on graph paper, but rather much more like grains of sand flung onto some invisible surface. By the 1800s, telescopes had become advanced enough to reveal that not all stars are the same. Some look like solid dots, others more like clouds. In the early 1900s, an astronomer had an epiphany when he saw a tiny flare of light turn on within one of these cloud stars. He suddenly came to an astonishing realization that this cloud star wasn't really a cloud. Rather, it was a large and distant clump or cluster of stars, and that he'd seen an exploding star within a huge and very far away star cluster. It turned out that the planets and stars of the universe were arranged in these swirling disk-like structures, separated by millions of light years of space, or even billions. Originally referred to as island universes, they are now called galaxies. Moreover, these galaxies are in motion and attracting one another through gravitational pull, the same thing that makes our Earth go around the sun. Isaac Newton discovered a fact of nature truly profound. The same phenomenon of nature that made the apple fall from the tree and hit him on the head is making these galaxies merge. It is quite common in the universe for galaxies to collide and merge to form larger galaxies. In fact, ours, called the Milky Way, will eventually collide with its much larger nearest neighbor, called Andromeda. If you were to be able to look from on high at all of the galaxies in the universe, you would see a pattern like this, crisscrossing threads and clusters, and empty voids. Intergalactic space is big, but it doesn't even register when you look at the universe from this much of a distance. The voids you see here are vast empty spaces between threads and clusters of galaxies. All of the light in the universe amounts to wispy threads amid a vast expanse of dark emptiness. But notice, this pattern is not like sand strewn across a table. In fact, if you were to zoom out more and more, you would begin to see that the universe is actually quite uniform, the same in every direction. Not only is the Earth's place in the universe completely ununique, the place of our galaxy isn't unique either. No place is. The same properties of matter and energy and forces of nature apply the same everywhere. Gravity, for example, is neither stronger nor weaker, regardless of where you are in the universe. Intriguingly, what appears to be special are these properties themselves, which scientists have measured with great precision. Everything that you or I or anyone has ever known in life, every plant, every animal that has ever existed, starfish, dinosaurs, birds, the simplest to the most thinking and feeling, all of it emerged from these exact properties of the universe. If these same properties of nature that gave rise to Earth and life and Isaac Newton are the same everywhere, and the universe is generally the same everywhere, then I imagine there could be another Isaac Newton out there, or someone much like him, or someone who maybe looked different but uncovered the same idea by means of the same methods, and so forth. As you can see here, these properties of matter don't appear to relate to any higher logic or organizing principle. So why are they precisely what they are? One thing is certain: if they weren't precisely what they are, and achieving the organizational balance we experience, we wouldn't be here to measure them and ask these questions. This leads to the idea of the multiverse. The reason the properties of our universe are what they are is because these properties have converged in a precise way in our particular universe, which is just one among many, perhaps infinitely many. This convergence occurred some 13.8 billion years ago in what's commonly referred to as the Big Bang. Albert Einstein and others believed that the universe must be static and eternal, that it is something that must simply be. Observation has shown otherwise. The exact properties of the particles, forces, and energy that our universe is made of has a beginning moment, or birth moment. And it turns out, one day the lights will go off and it will expire. This is a profound insight. The idea of the multiverse is that there must be other universes that have different values for their fundamental properties. Different masses for protons, for example, values for gravity, speed of light, and so on. Not all combinations of properties will give rise to the stable environment we experience here, nor to the complex biochemistry that makes us alive and conscious. In the 1800s, telescopes weren't as good as they are today, and the people saw much fuzzier images, like this one here. And so when they pointed their telescopes at Mars, they saw this huge canal running through the middle of it, and they assumed it must be a man-made canal built by some civilization living there on Mars. It's amazing how far we've come so quickly in terms of understanding the position of life and of human civilization in the context of everything that exists in our universe.